Right. Hello, everyone. Okay, so this video is just a redo of the lesson that I gave previously on my tips for balancing equations. So if you forgot the tips I gave you, or maybe you were absent that day, then this is for you. If you already know how to balance, then you don't have to watch this one. Okay, so here we go. I was originally having problems with my mic, and this is actually take 3, so forgive me if I sound a little bit frustrated. Okay, so when you're balancing equations, the first thing that I do, so these are my tips, is I take inventory of what I have without any coefficients. Okay, and I'll show you how to do it in a second. Okay, the second thing that I need to tell you before we begin is, remember, when you're balancing equations, you are not changing the formulas. Okay, so remember, balancing equations is where we're trying to get the same number of atoms on both sides of the arrow. This shows the law of conservation of matter. So when you're trying to balance, you cannot change a subscript. And the reason why is because in an equation, you're actually saying what is turning into what. So you have to properly, accurately represent what it is by its formula. For instance, H2O is water, and H2O2 is not water. Okay, so if you put a number here to try to balance the equation, you're saying, oh, I didn't mean water, I mean hydrogen peroxide. And that's not what it is, right? So water is not hydrogen peroxide. So when you are balancing the equation, you can only change the coefficients. Those are the numbers that are in front of the formula. Okay, so tip number 1. Okay, tip number 1, and I'm going to put this on pause so you don't have to, so this will be quicker for you, okay? Okay, so tip number 1, start with the most complicated molecule. Is where you begin when you're balancing equations can make the difference between a 30-second or less job, or it could turn into a frustratingly long process to balance. So my tips are more than these 4 tips in the world, but these are the 4 that I use. And they really help me out. So start with the most complicated molecule, which would be this one. So I'd start balancing by looking at this first. All right, so what I'm going to do to balance, I'm going to take inventory, and you don't have to do this for every problem. Some of these you can just do in your head. Some of them are easy enough, but you need to know this method in case you get stuck. Okay, so taking inventory means you're going to write down all the things that you're trying to balance. So on this side of the arrow, I have carbon, I have hydrogen, and I have oxygen. So I list them out. The other side of the equation, outside the arrow, you should have the same atoms. Okay, because you can't get an atom out of nowhere, and atoms don't just disappear. In a chemical reaction, what happens is the atoms that are on this side, they just rearrange into another configuration, and this is what they rearrange to. Okay, so we don't have any atoms lost or gained. So I'm going to list out those atoms again on this side, and I'm going to do it in the same order to make my job of balancing a little bit easier. So this way I can compare each one very quickly. All right, so taking inventory. How many carbons do I have on this side, on the reactant side of the equation? I have 2. I don't have any carbons anywhere else, so I'm going to put 2 there. And hydrogens, I have 5 here, plus 1 more, that's 6. And then I have 1 oxygen here and 2 oxygens there, so that's altogether 3. Okay, on the product side, oh, dang it, I wasn't supposed to write these. Oh well, got a preview. Okay, I have 1 carbon here, and I have 2 hydrogens there, and I have 3 oxygens there. Okay, so nothing's balanced. I don't have the same number of carbons, hydrogens, or oxygens. So I'm going to start with this molecule here, because that's my tip, most complicated one, and I'm going to look at 2 carbons here, and I want 2 carbons there. So that's why I had it 2 there. Okay, now that's going to change my tally. So what I do is I don't add on to this. What I do is I cross it out. I start all over when I count, when I take inventory again. So now I have 2 carbons, because remember the coefficient multiplies everything of the formula that comes after it. It does not pertain to any of the other formulas, just the formula that the coefficient is in front of. So this is saying I have 2 of these particles, which means I'm going to have 2 carbons, but it also means I'm going to change my number of oxygens. Okay, so I'm going to cross that out, and I'm going to retally my oxygen. So here I have 2 times 2, 4 oxygens, but I also have an oxygen here. So I got to add that to it. So I have 2 here, 1 there. 4 here, 2 times 2 is 4, plus 1 more, that's 5. Okay, so I have 5 oxygens on this side. Okay, now I'm going to go back here. This is my complicated molecule, and I'm going to try to balance the other side. This side has 6. I need 6 on this side, so I'm going to put a 3 in front of this. That's going to triple this. So now I have 3 times 2, 6 hydrogens. But I've also changed my number of oxygens. So I got to retally this. I have 3 represented here, 3 times 1. Remember, when there's no subscript, that means 1. So 3 here, and I have another 4 here. So 4 plus 3, that's 7. Okay, so now I've balanced my carbons, I've balanced my hydrogens. Now I'm going to try to balance my oxygens. Okay, this side has 7, this side has 3. How am I going to get, I need to get this side to say 7. Okay, now remember, I already have 1 here, so I need 6 more. So if I put a 3 in front of this, 3 times 2 is 6, then I add that 1 more, that gives me 7, and now it's balanced. I have the same number of carbons, hydrogens, and oxygens on both sides. Balanced. Okay, now on to tip. Okay, tip number 2. If you have an even and an odd, double the odd. Okay, so what does that mean? Let's first take inventory. Hydrogen, oxygen on this side, and I have the same hydrogen and oxygen on that side. I have 2 hydrogens and 2 oxygens there. And on this side I have 2 hydrogens and I have 2 and 1, 3 oxygens. Okay, so I have an even, the hydrogens balance so far. Okay, I have 2 oxygens on this side, 3 oxygens on that side. I have an even and an odd. So my tip is if you have an even and an odd, double the odd. So what is making my count of oxygen odd? This one. So if I double this one, okay, so now I'm going to retally. I change my number of hydrogens to 2 times 2 is 4. And I've changed my number of oxygens. This way I have 2 times 1, there's 2 here, 2 oxygens here, 2 oxygens there, so that's 4. Alright, now I can go to the other side and try to balance. I have 4 oxygens there, hydrogens there, I need 4 hydrogens here. So I put a coefficient of 2, that's going to give me 2 times 2, 4 hydrogens, 2 times 2, 4 oxygens, and I am balanced. Yes. Okay. Tip number 3, treat polyatomic ions as a unit if they exist on both sides. Alright, so I gave you a list of polyatomic ions earlier. It looks like this. So these are the list of very common, there's many more than these, but very common polyatomic ions. If you have polyatomic ions in your chemical equation that you need to balance, then the easiest way to do this, instead of listing every single element when you're taking inventory. Instead of doing that, you list them as a unit if they exist on both sides. For example, this is ammonium, and we have ammonium over there. How can you tell off the bat if you have polyatomic ions? Where your parentheses here give you a clue. Okay, so I have NH4 in parentheses here, and it exists there on that side. So I am going to list that as a unit. Okay, and then PO4, it's over here as well. That is a polyatomic ion. It's actually called phosphate. So I'm going to list that. Okay, and then next I have lead. Lead is not a polyatomic ion. Poly meaning more than one atom ion, so it's just a single ion. And then I have NO3, which is nitrate. And see, it's in parentheses, so I know it's there. And I have to check to make sure it's on the other side before I can list it. I cheated, because I already know it's there. NO3. Okay, so, and I think that's it. That's it. So I can list the same things on this side. NH4, PO4, PB, NO3. Okay, so now I'm going to take inventory just like I did before. I have 3 NH4s, 3 ammoniums. Okay, the 3 outside of the parentheses. I don't have 4 of them. Remember, this 4 is part of the polyatomic ion. There are 4 hydrogens and 1 nitrogen stuck all together that make up this ion. Okay, and then I have PO4, only 1 of them. Okay, I don't have 4 of them, I have 1 of them. PO4, that's all one thing. Okay, and then I have 1 lead, and I have 4 NO3s, 4 nitrates. Okay, and on this side, I have 1 NH4, 1 ammonium, and I have 4 phosphates, 4 PO4s. Okay, I have 3 leads, and I have 1 NO3, 1 nitrate. Okay, so taking inventory is done, and now let's start balancing. So everything was pretty complicated. I think I'm just going to start on the left-hand side here. I have 3 ammoniums. So I need 3 on this side. So I'm going to put a 3 in front of this, which is going to change my ammoniums and my nitrates. So now I have 3 times 1, 3 of these, and I have 3 nitrates. Now, because of this coefficient, right? Okay, now I'm going to go down to the next one. This is my PO4. I have 1 on this side. I have 4 on this side. So I'm going to make this a 4 by putting a 4 in front of this. I have to put it in front of the formula, okay? I can't put it in between. This is all one thing. See how there's no plus in here? This is all one thing. So I've got to put the coefficient in front of the whole formula. Now, when I do that, I'm also changing my ammoniums here. So how many ammoniums do I have now? 4 times 3. That's 12. And how many phosphates? 4 times 1? 4. Okay, so that balanced my phosphates, but I've thrown my NH4s out of balance. I need 12. This one says 3. So I've got to go here and change it now to a 12. And that seems like, oh my gosh, it's going to get really, really complicated, but trust me, just follow this method and it'll all work out in the end. Okay, so I put a 12 in front of there, which means now I have 12 ammoniums, right? 12 of these guys, but that means I've also changed my nitrates. That's 12 as well. Okay, so I've balanced NH4s, I've balanced PO4s. Now we're on to lead. I have 3 on this side, so I've got to put a 3 here. That's going to change my number of lead to 3, but it's also going to change these nitrates. So how many nitrates do I have now? I have 3 times 4, which is 12. And voila! It is balanced. 12, 4, 3, 12. Okay. Where is my cursor? There you are. Okay, so here is the last tip. The last tip says try doubling. And that's a 5, by the way. Okay, so we'll start out the same way. CHO on this side, CHO on that side. I have 5 carbons, 10 hydrogens, and 2 oxygens here. On this side, 1 carbon, 2 hydrogens, and 3 oxygens. Okay, I am going to start with the most complicated molecule, so I'm going to balance my carbons first and then my hydrogens. So carbon, I need 5, so I'm going to put a 5 in front. That changes my carbon count, and it also changes my oxygen count. So how many oxygens do I have? I have 5 times 2, that's 10, plus 1 more, that's 11. Okay, 11 oxygens total represented there. Okay, next, hydrogens. I have 10 on this side. I need 10 on this side, so I'm going to put a 5 here, which is going to change my hydrogens and my oxygens. Hydrogens and oxygens. So how many hydrogens now? 5 times 2, it's 10. And my oxygens, I have 5 times 1, that's 5. But don't forget about these guys. There are 10 of them here. So 10 and 5 make 15. And I've balanced my carbons and my hydrogens. But now I'm on my oxygens and I see a problem. The problem is, it doesn't matter what number, what coefficient I put here, it's always going to give me an even number. But I need to make 15. There's no way I can do that. So, try doubling. So I'm going to put a 2 here, double that. I'm going to double this, make it a 10. Double this, make it a 10. And let's make sure that we got the right numbers here. So we're trying to get to oxygen. So we're going to check carbons and hydrogens. So right now I have 2 times 5, 10 carbons. And I have 2 times 10, 20 hydrogens on this side. Okay, the carbons on this side, 10. And the hydrogens on this side, 10 times 2, that's 20. Okay, so my carbons are still balanced, my hydrogens are still balanced. Okay, now how many oxygens do I have? I have 10 times 2, that's 20, plus another 10, so 20 and 10 make 30. And now it's an even number, so I can put a coefficient here to get to 30, and that coefficient will be 15. 15 times 2 is 30. Okay, so that's how you do tip number 4. All right, guys, that's it. So if you were having trouble with balancing before, please go to the past worksheets I gave you and practice. You do need this for stoichiometry. Bye.